My name is Syarul Saiful Aswad. My metric number is 2025195667. And we will introduce to you the chemistry properties of water. I will be conducting an experiment to show the boiling point of water, which is in liquid form, against others aqueous solution of salt and sugar that dissolve in water. Thank you.
My name is Muhammad Adnan Daniel Basmiti. My metric number is 2025194501. So I will conducting experiment about 3 steps of method of water.
My name is Muhammad Rais Hazri bin Muhammad Rahmat. My metric number is 2025111937. I explain about how salt and sugar dissolve in water.
Hi, my name is Muhammad Lukman bin Leman. My metric number 2025507811, and I will introduce about evaporation.
Hi, my name is Ahmad Faizal Fan bin Muhammad Zaidil. My metric number is 2025194295. I will be explaining how water's polarity leads to important chemical properties like cohesion, surface tension, and adhesion. Thank you.
I will talk about how water can change state. So, first one, ice heat up and become water. This process is called melting. It's when solid will turn into liquid. Next, water cool down and become ice. This process is called freezing. When liquid will turn into solid. Next, water heat up and become a steam. This called evaporation. Is for liquid turn into gas. Next, steam cool down and become water. This process is called condensation. It will turn gas into liquid. Next, ice turn directly to gas without melting. This process is called sublimation. It turns solid into gas. And last not least, gas turn directly into ice. It's called deposition. Gas into solid. So, quick reminder that when the molecule is heat, the particle will move faster. So, it will become solid, then liquid, then gas. But when it cool, particle will slow down and it will go gas, turn into liquid, and then lastly solid.
In this experiment, we will turn ice solid into liquid, then into gas. Look at this ice cube. It's solid because its water molecules are locked in tight, orderly pattern. The molecule vibrate but cannot move freely when we add heat. Heat energy make the molecule vibrate faster, breaking the rigid bond. Now they slide past each other. Is liquid water. Notice how it takes the shape of the container? That is because the molecules are close but not stuck into place. Then when we keep heating, the molecule gain so much energy they break free entirely, becoming water vapor. What you see as a steam is actually tiny liquid droplet, but the true gas is invisible. The molecules are now far apart and move widely, filling the air.
Hi everyone, today I'm going to explain how sugar and salt dissolve in water. First, I'm gonna put sugar in the water. You can see here, sugar dissolve in water. And now I put the salt in the water to see how it dissolves. Tak pasal kena cut.
Boleh lah, boleh.
Ni aku lupa aku pakai macam ni.
Santai, relax. Okay, takat tu dah. Tapi tu nak cerita pasal garam ah?
Aku nak explain lah. Satu-satu.
Dah explain?
Belum. Aku boleh letak.
Oh.
Tak kau cakap tu je. Ni dah kira seorang. First, let's talk about sugar. Sugar or sucrose is a covalent compound. When it dissolves in water, it does not break into ions. Instead, the sugar molecule stay whole and spread out evenly in the water. This happens because of hydrogen bonding between the sugar and water molecules. Since there are no free ions, sugar cannot conduct electricity. That's why sugar is called a non-electrolyte. Now let's look at salt. Salt or sodium chloride is an organic compound. When salt dissolves in water, it breaks apart into sodium ions and chloride ions. The water molecules surround these ions and keep them separate. This process is called ion-dipole interaction. Because salt produces free moving ions in water, it can conduct electricity. That makes salt an electrolyte. That's all.
Now, follow me friends, we will observe the boiling point of water against other aqueous solution, which is sodium chloride and sugar solution as mentioned before. We will have 3 beakers for each solution, and all the solutions are prepared by Rais. Thank you. We'll be using 25 ml of water in each beaker. Here is the sodium chloride and sugar. In the end, we are expecting water to boil faster than other solutions, followed by sodium chloride, and the last one should be sugar. Friends, the experiment is done and boiling point were recorded. Water reached the boiling point at 3:46 seconds, sodium chloride at 5:34, and sugar is the last one, 5:59. So the results do obey our theory. And why did this happen this way? Because water boils faster than sodium chloride. It has no solute, so it will boil faster, and sodium chloride boils faster than sugar at same mass and same volume of soluble, because sodium chloride dissociates into more particles, causing a higher boiling point elevation. That's all from me. Thank you.
Assalamualaikum and hi everyone. My name is Shuman and today I want to talk about evaporation, but more to talk about evaporation in the lake. Firstly, we need to know what is evaporation. Basically, in chemistry, evaporation is the process by which liquid molecules at the surface gain enough kinetic energy to escape into the gas phase, turning into vapor without boiling. Interesting, right? Because turning into vapor without boiling, it occurs below the boiling point of the liquid and only surface molecules with sufficient energy can evaporate. It's also a cooling process because higher energy molecules leave, lowering the average energy and temperature of the liquid. So, that's the explanation about evaporation. Let's talk about evaporation in the lake. Basically, evaporation is the process where water from the surface of the lake changes into water vapor and rises into the atmosphere. When the sun hits the lake, the water molecules gain energy and evaporate into the air, playing a key role in the water cycle on hot and windy days. The rate of evaporation from the lake increases, causing the water level to drop more quickly. So, evaporation is a physical change that occurs when water molecules at the surface of the lake escape into the gas phase without boiling. Evaporation from lakes contributes to cloud formation, which eventually leads to precipitation and keeps the water cycle moving.
Hi everyone, I will be explaining how water's polarity leads to important chemical properties like cohesion, surface tension, and adhesion. A water molecule H2O is polar because oxygen is more electronegative than hydrogen. This causes partition charged oxygen become slightly negative and hydrogen slightly positive. This polarity allows water molecules to form hydrogen bonds with each other. Because of these hydrogen bonds, water molecules stick together. This is called cohesion. Cohesion creates surface tension, which allows water striders to walk on waters without sinking. Because of these hydrogen bonds, water molecules stick together. Water also sticks to other materials. This is called adhesion. You can see adhesion when water clings to the sides of a glass or move upward in a thin straw. This helps plants pull water up from their roots. So, thanks to water's polarity, we got cohesion, surface tension, and adhesion. All this essential for life and nature. Thank you.
Alright team, great work today. Now we will be conclude our experiment that we explored today about chemical property of water. I'll start with mine. When we compare the boiling point against water and other aqueous solutions such as dissolved salt and dissolved sugar, we found that water have lower boiling point against the other solution. So let's go with the next experiment.
And we can also observe water in three states of matter is solid, liquid, and gas. That's all for me.
The same polarity gives water its role as a universal solvent. In our experiment, water dissolves both salt and sugar. Salt breaks into ions, sugar forms hydrogen bonds. Different mechanism, same result. Water enables countless chemical reactions in living system by breaking substance down at the molecular level.
Let's tie directly to water's polarity. Because water molecules are polar, they form hydrogen bonds with each other, which leads to cohesion. The tendency of molecules to stick together and surface tension. This is why water forms bridges on surfaces and why small insects like water striders can walk across a pond without sinking. The surface acts like a tight skin, strong enough to hold their weight.
Lastly, and standing near the lake, I talk about evaporation. As sunlight hits the surface, some molecules gain enough energy to escape into the air. It's slow but constant, part of the natural water cycle. Without it, we wouldn't have cooling mechanism, weather, or even climate regulation.
So in short, water isn't just a liquid we drink or see. It's a chemical powerhouse that leads to tension, cohesion, solvent abilities, and phase changes and interactions with solute. So every drop reflects a balance of chemistry and function, and that's what makes water essential to both science and life.